Hello students. So we are back with our PYQ series and today's topic is clocks. It's a bit tricky topic because movement of multiple hands and movement along the circle. So geometry is also involved. So you need to be clear about your concepts of geometry, especially the properties of circle and how angular measurement works. But some of the questions are very easy, very direct. For instance, this is CSE 2022 question. Question was, how many seconds in total are there in X weeks, X days, X hours, X minutes, and X seconds? So simply, if you replace X by 1, and you find out the answer, and then in X times that would be simply whatever number of seconds are there in 1 week, 1 day, 1 hour, 1 minute, and 1 second, that multiplied by X, because we can calculate for 1, and in X, because everything becomes X times in X weeks, X days, X hours, etc. So everything becomes X times. So seconds also become X times. So all we have to calculate is find out number of seconds in 1 week plus 1 day plus 1 hour plus 1 minute plus 1 just second. So that these many plus 1 second. In seconds, in all of them we have to tally. So we know that 1 week is 7 days. 7 days is 24 into 7 hours into 24 into 7, these many hours, and each hour has 60 minutes and each minute has 60 seconds, right? These many seconds in 1 week. For 1 day, we have 1 day has 24 hours and each hour has 60 minutes, 60 seconds. 1 hour has 60 minutes, 60 seconds, and 1 minute has 60 seconds, and then 1 second has 1. What is the answer? Answer is simply addition of all of these things. 1 plus 60 plus 60 into 60 plus 60 into 60 into 24 plus this thing plus 60 into 60 into 24 into 7. Correct? From these three things you can take, this is 61, this is 61. So logically also these will all have 2 zeros at the end, and here this is 61 at the end. So number would be something like 61 and other things. 61 would be at the units and tens place, because 60 plus 1 is 61, and everywhere else you will have 2 zeros. So nothing in the nothing when we add all those terms would affect whatever this 61 that is coming at the units and tens place. So at the end we should have 61 and then other things. So where is 61? Only one place. Answer here is D. You can calculate fully and verify that that is in fact the answer, but absolutely no need to fully calculate here. Let us move on. Next question. We have two statements and we have to say we have to comment upon which of them are correct and which is not. First, between 3:16 p.m. and 3:17 p.m, both hour hand and minute hand coincide. Now, as a rule, if you have ever observed the watch, minute hand travels very slowly at it covers 30-degree angle in 60 minutes, but minute hand covers entire 360-degree angle in 60 minutes. It travels fully, no? So minute hand, whatever the hour hand may be, minute hand will come and cross it, right? Will cross it, right? And that will happen every minute, because minute hand covers entire thing. We are talking about, okay, minute hand and hour hand. So okay, sorry, we are not talking about second hand. Second hand all statement is this. So second hand covers 60 seconds, entire circle in 1 minute. So between every minute, it will minute hand and hour hand will cross, and there is only one exception for this. Exception is between for example, it's a 4:59 and 5 o'clock. 4:59 and 5 o'clock. minute and second hand will not cross in between, but at exactly 12, at exactly pi. So it is only except for that instance, minute and hour hand cross each other or coincide each other between every 2 minutes. So statement 2 is absolutely correct. Statement 2 is correct. Now we have to check statement 1. Fine. Let us see. Let me draw a clock. We have 3 o'clock like this. 3 o'clock looks like this. Here we have 1, here we have 2, here we have 4. And we are talking about 316 and 317. So that is between when this comes here, and it is the minute hand will cross our hand somewhere in between 3 and 4, right? So where does it exactly coincide? That is what question is, in between what time. So now look, this is 90-degree angle. Minute hand travels at the rate of 6 minutes per minute hand travels at the rate of 6 degrees per minute, because in 1 hour or 60 minutes it travels entire circle, which is 360 minutes, 360 degrees. So in 1 minute it travels 6 degrees, and our hand travels 30 degrees in 60 minutes. So each minute, in 1 minute, our hand travels half a degree. So in essence, if we see what happens in essence, that this will travel, the minute hand will travel at the rate of 6 degrees per minute, and our hand will travel at the rate of half a degree per minute. So in essence, the minute hand will go towards our hand, or reduce the distance between their between minute hand and our hand will be reduced at the rate of 5.5 degrees per minute. He is going at the rate of 6 degrees ahead, and he is going at the rate of half a degree ahead. So at the rate of 5.5 degrees per minute, distance between them is decreasing. So we have initial distances. So 5.5 degrees you will get reduced in 1 minute, right? For how much time would it require to reduce 90-degree distance, which was initial distance? It will go to 0 when they coincide, and reduction is at the rate of 5.5. So this is a simple question now. We have this is equal to 90 by 5.5 is equal to 900 by 55 is equal to, we can divide by 5, we have 180 by 11 is equal to let us see where does it happen. 11 1s are 1, 7 0, 11 6s are 66, 4 0, then 11 3s are 33, and so on. So after 16 minutes and before 17 minutes it will happen. So this is also correct. Again, this may seem difficult because you may not have learned this topic earlier, but once you learn this topic, once you learn the basic concepts that revolve around this topic, once you learn how the movement of minute hand and hour hand actually looks like, and do some practice, this is actually very regulation question in that sense. Next question. This is a very easy question, very direct. You can guess also. Question is, at which of the following times do the hour hand and minute hand of the clock make an angle 180 degree with each other? We want exactly 180 degree with hour hand and minute hand. We have 1 o'clock here, we have 7 o'clock here. So at exactly 7 o'clock, hour hand will be on 7 and minute hand will be on 12, right? So at 7 o'clock, this angle is definitely not 180 degree. It is this is 8, this is 9, 10, 11 and 12. This is 1, 2, 3, 4, 5. So it is 150 degree here. So it is not 180, definitely. So now what will happen? This minute hand will go ahead, this hour hand will go ahead, and in 5 minutes at 7:05, this angle is, this minute hand will come exactly at 1, and but our hand will go slightly ahead. So the angle now is, this angle is less than 180, this angle is more than 180. In between that, has anywhere the angle been exactly 180 between 7 and 7:05? So this is look at this angle. This is 150 at 7. It increases, keeps on increasing always, because this hand travels faster. But even at 7:05, the angle is not yet 180, so it was never 180 in between this as well. So it has to be option number D. After this, the hand will come here, and somewhere here, the angle would be exactly 180 degrees. That is how you look at it or observe it. In examination hall, one hack could have been, for this question, you actually take out your watch, analog watch, and just look when does it happen. That could be the another hack for this kind of question. Next question. Question is, a wall clock moves 10 minutes fast in every 24 hours. The clock was set right to show the correct time at 8 a.m. on Monday. Okay, fine. The clock moves 10 minutes fast in 24 hours. It shows correct time at 8 a.m. Monday. Okay. Then when the clock shows 6 p.m. on Wednesday, what is the correct time? Fine. So firstly, at 8 a.m. Monday, it is showing correct time. Now let us see how many hours have elapsed between these two. It is 8 and here it is 6 p.m. on Wednesday. So 8 a.m. Monday to 8 a.m. Tuesday, one entire day. Tuesday to Wednesday, 2 entire days, so 48 hours. And then from 8 to 4 plus 6, 10. Right, 48 plus 10. So it is 58 hours. So clock actually has moved ahead by 58 hours. Correct. Now the thing is, in 24 hours, clock gains 10 minutes. So in reality, when 24 hours happen, the clock actually goes ahead by 24 hours, 10 minutes. When the reality goes ahead by 24 hours, the clock goes ahead by this time. Now question is, if clock goes ahead by 58 hours, how much the reality has moved? Now you can see that there are some hours, there are some minutes, but so easier thing could be that we convert every hour into minute and solve this question. So 24 hours is 24 into 6 minutes. So this is 24 6 is 144. So this is 1440, and you just add 10 to it. So it is 1450. 58 hours is 58 into 60, which is, you can calculate, 3480. Question is, how many minutes the actual time has elapsed if this is the time elapsed as shown by the clock, which is faulty. It is simply, the ratio has to be same, no? So it is, if we assume that this is x, so we have x upon 1440 is equal to 3480 divided by 1450. Let us bring 1440 on this side. So x is equal to 3480 divided by 1450 into 440. Correct. Now these many minutes is the answer, and those minutes you need to then convert into hours, and how many hours, how many minutes have elapsed, that we need to find out. Is there any factors that that are common here? Here we have 5. If we divide this by 5, how much we get? These factors of 145 is 29 into 5, no? It's 29 into 5. And is this divisible by 29 then? Yes, 29. 5s are, and this is 29 ones are 1, 5, 8, 29 2s are 58, and 0. Right? And we can further divide by 5. So we have 5 2s are 10, 5 4s are 24 4s are 120, and you can multiply this. This answer is 24 4s are 96. 24 4s are 96. 96 plus 9, 105. 26 ones are 1. 26 ones are 24 plus 10. So 34. These many minutes 3, 4, 5, 6 minutes have elapsed. Now we convert this into hour by we just divide by 60. So we have 3, 4, 5, 6 divided by 60 is equal to, I want to see how many complete hours have gone by. So it is 6. Let us divide by 6 and keep 10 as it is for now. 6 5s are 30, 4 5 6 7s are 42, 3 6 6 6 are 36, and because we are dividing by 60, so it is 57.6 hours. 57.6 hours, and this faulty clock shows 58 hours. So we have to go 0.4 hours back from 8 on from 6 o'clock, and 0.4 hours is nothing but 24 minutes, because 1 hour is 60 minutes. No? So 0.4 is equal to 6 into 0.4, so 24 minutes. So you go 24 minutes back from 6 o'clock. Answer here is, sorry, 5:36 would be the answer. Right? 24 minutes back from 6 o'clock. This was a bit different and complex problem, but again doable. Something which just requires practice to get better with this kind of problems. So I think that was the last question that was asked on clocks in last 5 years. I hope it was helpful, and we are starting our CSAT Foundation batch from Monday, 8th of January. You are welcome for demo lectures. First 2 lectures would be demo lectures, and see if it is correct suit for you. And I hope to see many of you together, many of you in our class, and we'll meet in the next lecture. Thank you.